With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, let us have a look at the question first of all, which is that in context of the lanthanoids, which of the following statement is not correct, right? And we have been given here 4 set of statements and we need to find out that which one is the incorrect one. Now let us take them one by one. So the first one says that there is a gradual decrease in the radii of the members with the increased atomic number in the series. So this is a correct statement. How we can say that? Now if we just move across the series from left to right, which means from cerium to lutetium, we generally experience that the atomic and the ionic radii has a gradual decrement, right? It decreases gradually. So why it is so? So this can be explained on the basis of 2 things. The first one is nuclear pull, right? So if we just move across the series from left to right, the atomic number increases by 1 unit, which means that the nuclear pull will also increase, right? And as the nuclear pull is increasing, which means that the valence electron will now be more attracted or more bounded towards the nucleus, and due to this reason we see that the atomic or the ionic radii gradually decreases. And the second reason is lanthanoid contraction, right? So what exactly is lanthanoid contraction? So we know that according to the general, we can say electronic configuration, which is n-2, we have 4f 1 to 14, then 5d1 2, and we have 6s 2, right? Now according to this particular configuration, we know that before d in lanthanoids 4f orbitals are filled, right? And we know 4f orbitals are pretty diffused ones, which means that they are going to cast poor shielding effect, right? And as they are going to cause poor shielding effect, which means that the valence electrons are now more attracted or they are more bounded towards the nucleus, and due to this reason we can again say that the atomic and ionic radii will show a gradual decrement, right? Having said that, now I can say that this particular statement is the correct one, which means that this will be an incorrect option. So this one is the incorrect option for us. Moving on, the next one that we have here says that all the members exhibit +3 oxidation state. Now in lanthanoid series, as we all know that the most common oxidation state that we have, okay, is +3, right? So it shows +2, +3 and +4 oxidation states, but the most common that we have is +3 oxidation state, right? And this can be explained on the basis of low ionization potential, right, for the formation of any lanthanoid +3 oxidation state, right, which is comparatively very low, if I have to compare with other series. Now this is favorable, so this is the reason why this is the most common oxidation state. So this particular statement is the correct one and the incorrect option for us. Now moving on to the next one, says that availability of 4f electrons result in the formation of compounds in +4 states for all members of the series. Now this particular statement is incorrect because all the members do not show +4 oxidation state, because the formation of +4 state requires very high energy, okay, requires very high energy, okay. So just because it requires very high energy, so for +4 oxidation state is not very common in all of the among all the elements in the series, right? And also we can explain it like that because it is pretty nearer to the nucleus, and just because all the electrons are more bounded towards the nucleus, so it will require higher amount of energy to eject those electrons, and this is the reason why it will we can say not show plus 4 oxidation state. So having said that, I can now say that this is the correct option because this is the incorrect statement that we have here. Now moving on to the last one, because of the similar property, separation of lanthanoids is not easy. Yes, this is also true. The separation of lanthanoid is not easy. We can say like that. So the size of many of the elements like zirconium and hafnium are similar, right? Similarly, we have similar Nb and Ta, right? So these elements have similar size. Similarly, we have Mo, that is molybdenum, and tungsten, right? So all these elements have similar size, okay? And just because they have similar size, they show or depict similar properties, okay? And just because they all show similar properties, the separation is not easier, right? So this particular statement is also a correct one and the incorrect option for us, right? So this is how we can solve this question. The fourth option is also incorrect. The third option that we have is the correct option for us, which is the incorrect statement. I hope this is clear to you. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.